comma 1 because I do not want the constant to be set to 0, comma 1 because I do want all the statistics. Let's see, Alt Shift Enter, or Control Shift Enter. It's Control Shift Enter. What I really need is the slope and the intercept from this, which I'm going to use in the calculation a little bit later. And I also need the post period out here, because what I'm going to do is extrapolate this back to some time right in here or so. That's the time that corresponds to temperature at 60% of total rise. Remember that? I'm going to use that. I have to extrapolate both this line and that line to that time. So I need this line too. It looks like everything after 15 minutes is probably enough data there to give me a good line. So I can come down here and set up another line-S thing. And go from 15 minutes down with my temperatures, which are Y's, my times, which are X's, 1 and 1, because I want the constant to not be set to 0, and I do want statistics. Control Shift Enter, and there I have it. What I really want is slope and intercept, but I have the rest too. And what do I want to do with that? Well, I need to find what's called the temperature at 60% total rise. So I need to get a crude delta T, which is going to be the maximum temperature minus the temperature at the time of firing. And then I'm going to take 60% of that. So I have down here dT crude, except that T should be a capital T because it's a temperature and not a time. The capital D should be a delta. So I'm going to find the symbol menu and make it a delta. And crude probably should be subscripted. Delta T crude. Well, what's my maximum temperature? I can find it here. It looks like it's 25.7273, 74, 748, 51, 53. That looks like it's the highest temperature right there. And I'm going to subtract from that the temperature at the time of firing, which is conveniently in red here. I put it that way specifically so we would know when it was fired. So my crude delta T is 2.474 degrees Celsius. Turns out that's a couple tenths of a degree too low. But to find that, we have to do the rest of this. We need to find the true high temperature. And I didn't want a superscript, I wanted a subscript. Shame on me. And we need to find the true minimum temperature, or the true low temperature. And to do that, what we're going to do is extrapolate both of those lines to the time at 60% of the crude delta T rise. So we need now, we're not ready for those yet. I'm going to call this T60 for lack of any other useful name for it, which is going to be the temperature at 60% of the rise time. And that, surprisingly, that is just equal to the crude delta T times 0.6. 60% is a fraction of 0.6. So that is actually 60% of delta T crude, but what is the actual temperature there?